Forge Hydrocarbon is a university spin-off company. It's technology from my lab that was commercialized through Tech Edmonton.
The exciting part of this technology is that it can convert waste oils and fats that are non-edible into hydrocarbons that are exactly compatible with the existing gasoline and diesel and solvents pool.
What we're working on right now goes back to 2003 and really looking at the conversion of oils and fats into hydrocarbons. So Forge Hydrocarbon, the new company, is born out of a technology in our lab that really focused on how to use low value and inedible oils and convert them to diesel, gasoline, jet fuel without the use of hydrogen or other catalysts.
Let me give you an example. This is unedible corn oil, and this is what we make. This is the hydrocarbons that we make. This will be indistinguishable from what you're putting right now into your car or into your truck.
Again, stuff right now that's a cost to dispose of, we're looking to create value-added opportunities.
And so having the ability to take an undervalued product or waste stream and put it through a technology like this allows for more revenue creation and wealth creation as well.
The green aspect is the fact that this technology utilizes agricultural feedstocks. So we can easily plant the feedstock, utilize it, and regenerate it the next year.
The original idea behind it started really in 2003 with a crazy research idea. That project was funded by NSERC through a discovery grant, which is really the beginning basic science. From that, we got funding from the Alberta Agricultural Research Institute, which later became Alberta Innovates Biosolutions, to take it from basic to applied research. Once we did the applied research, we had to scale it up, and we got some equipment from Enterprise and Advanced Education that allowed us at a 1 liter scale to translate from a thimble to a 1 liter reactor, which allows us to scale up kind of phase 2 on the commercialization pathway.
So this technology was developed right here in Alberta and is going to have a global impact because it can be translated into any part of the world and utilized.
The fact that this technology was born in Alberta and built upon the oil sands style technologies really positions Alberta to be a leader in tomorrow's renewable energy economy.
It shows that coming together of energy, of agriculture, of forestry, some of the key industries in the province of Alberta.
There's your collaboration between Campus Alberta, being in this case University of Alberta, doing pure research and then developing a product that obviously has phenomenal commercial application throughout the world.
We could sense early on the impact that this technology would have and hadn't seen anything quite so transformative up until that point in time.
And it's going to be these kind of enterprises that are sort of the next generation, the next decade, where we're supplying a need that the society has identified.
So what we project is going forward, being able to use very cheap feedstocks, being able to use a relatively robust and sledgehammer approach in terms of the conversion allows us to do things very economically.
This technology is an example of how fundamental research and chemistry and applied chemistry together with expertise in the oil sands sector could produce a truly commercially viable technology in the renewable space.
The impact this research is expected to have is to really create jobs, create sustainable renewable technologies that allow us to make the traditional chemicals, fuels, even diluent for the oil sands out of byproduct and waste materials coming from the agriculture and forestry sector.
When we think of Alberta, we think of energy, we think of agriculture, but research and development and commercialization can be another economic engine for this province, so it's utmost important to our province.
By doing these types of technologies, I believe we're driving value back into the farm gate, helping the producers of the province get a more robust and sustainable business model instead of just making cheaper and cheaper feedstocks.